audible? Okay. Hi, this is Keshwam Degoda from FFSB Benchmark. So what we talk about now is FFSP and IOzone. FFSP is a new, I think I've been introduced like this, it's been a year. It's a new comparatively to IOzone. So we see the IOzone, lot of features are, since it is quite old, lot of features are known to many people. We see the FFSP features mainly, compared with IOzone. And we see the internals of these two tools. And we compare the results, and we'll see how to cross-compile these two tools for ARM-based SoCs. So particularly, I have taken an example of the that's our agenda for today. And we will end up in complete summary of FFSP and IOzone. I have personal comment on usage, the way of usage, how FFSP has to be used, IOzone has to be used. Okay, so let's start with the FFSP overview of FFSP. So FFSP stands for the Flexible Filesystem Benchmark. Unlike other tools, it actually requires a script kind of file, which is what we call it as a profile files, as an input. So this tool, the way invocation is FFSP, and the input is the profile file. And this mainly uses the P threads, POSIX threads for the file system benchmarking. And this tool, we can limit the time of benchmarking execution time. And in this tool, what we have is we can use a single profile to benchmark multiple file systems. And of course, let's say for a thread, for a benchmarking thread, we can assign what are the most probabilistic operations. Let's say if I want to do more read operation than write, so I can have a more probabilistic value than write. So we can assign the probabilistic values to the read, write, append, create, delete operations. So as an input to FFSP, the profile file. Profile file contains mainly three options. One category is the global options, which is applicable for the complete profiling operation, for the complete benchmarking operation. Other one is the file system options. So these are the set of options that you can give it per file system. And the thread group options. So in a thread group, you can have multiple threads or a single thread, which can operate on either on a file, one single file system or multiple file system. So there are options to characterize how the thread group should behave. So here, let's start with the global options of the profile files. What do we specify? First thing is how much time you need to benchmark. That's the time. Duration of the benchmarking operation. This is actually the mandatory field that you have to fill in. Otherwise, what happens is it just FFSP just starts and immediately sees that I don't have a time and it is a zero. I need to finish without benchmarking, it comes out. So other one is the direct time operation. So this is actually the optional one. If you give it, what it means is it will all write operations or read operations directly retrieve or return to data to the storage device. There won't be kernel buffers used if you enable this option. Aligned IO is you have to align the buffers for the 4K boundaries. Callout is something like the precondition or say some script file that you can execute before start of the benchmarking operation. So let's say I want to list the files first and then I want to start the benchmarking. So callout can be assigned with the ls command. So coming to the file system options. As we know, whenever we mount a file system, there will be a mount point. We generally mount it to some directory. So that's what we mentioned it in a location. And how many files should exist in a file system. That is actually given by the number of files. How many directories, number of directories. What is the maximum size of the file? That is the max file size. Minimum size of the file, min file size. While creating a file, what should be the block size that you are going to use? That is a create block size. Let's say you have started a benchmarking, and if the files are already existing, so if you want to reuse it, you can enable that option by using the reuse option.
So it will create files and directories according to.
Sorry?
It will create as a preparation state.
Yes. Yes. So this is actually the before the benchmarking. I'll prepare all those files first.
Can you specify also size of those files?
Sorry?
Okay, file size.
Yeah. And the differentiating feature of the FFSP is the aging the file system. Generally, most of the file systems, let's say you format it and you start doing the benchmarking. That's a time actually it gives always the best performance. Once the file system, once you start feeding the file system, it will take a lot of time to create a new IOzone, okay, and creating a data blocks, everything. So generally, once you start seeing a performance degradation, when file system starts feeding with the data, let's say 70% is already filled with the data, for the remaining 30%, generally 30%, generally it takes a lot of time. So in order to measure the performance in those conditions, FFSP has a unique feature, which I haven't seen with IOzone and any other tool. That is called, how do we age the file system? What it means is, before you start file system benchmarking, so you can fill with a certain data, and then start the benchmarking. So that we can have the option with AgeFS. So once you enable the AgeFS, you have to describe how you are going to fill the file system also. For that you have to define a thread group. So in that thread group you can mention how many threads that you wanted to have it to fill the data, and how much the block size that you wanted to write, how much is the write file size that you wanted to. Let's say here in the example I have taken 64 MB. Each write size is of 4K. And the write weight is actually the probability of the write operations. Generally, while filling the data, I don't need a read. So write weight, if I assign it to 1, and if I don't mention any of the probability values for any of the operations, so what it does is it only does the write operation. So for after mentioning the age of this, I have seen with FFSB 6.0 RC2 that once you mention the age of this, it is mandatory you have to mention the thread. Otherwise, what happens is not even actually gives you the error and other things. Supposed to, but it actually crashes. So use it with safety. Age of this, whenever you mention it, and you have to specify how many threads that you want to have, and how much is the file sizes that you are going to write. Having done, is that okay? It doesn't mean that it will write only 64 MB and start doing a benchmark. What it does is, it is actually the relative to the file system size. Let's say my file system size is 1 GB. Especially in the flash storages and all, because of the garbage collection, everything kicks in. Maybe so after 25% you wanted to start the benchmarking and all. You can specify that percentage. So that is why the desired routine. So it does, whatever the value, the real number that I want to specify, it is actually, the value is something like number of used blocks divided by total number of the blocks in the file system. So whenever I start filling it, and this, the value kicks in to 0.02, it means 20% of the file system is full. So it immediately comes out of the age thread group. It means my 20% of the file system is full. Now I can start the actual benchmarking operation. So this is what the desired routine means. And while writing data for the file creation, so you can mention the block size also. This write block size actually, what I say is, while doing the write operation, this is actually while opening the file, you can use this block size. Of course, if you don't use it, the default change will be the 4K. So this is actually the differentiating feature which I have seen with the FFSP. So once we did all these things, this actually the AgeFS, which you can have it per file system. So in a single profile, you are profiling for multiple file systems. You can have a different aging for a different file systems. So now we have seen the global options and the file system options. Okay. So now it comes to the thread group. So this is actually the major thread characteristics defining area in which actually it will start doing the profile. So in the thread group, we can mention whether we have single or multiple thread groups, and each thread group should on which file system it should operate. That can be defined with the bind FS. Let's say I have 5 threads. That one thread is operating on one file system. 4 threads can be operating on one file system. So this is what I can mention it. One thread group to which file system it should operate. How many threads I can have? What is the write size? Write size is something that it is not actually need not be the file size actually. It is actually whenever the thread starts fixing for the execution, it is actually the amount of data it writes to the file. Similarly, the read size. Read size is the amount of data it reads in every iteration. And the write block size. Let's say 64 MB is my write size and 4K can be my block size. So whenever the thread is for the execution, so it writes 64 MB in terms of 4K block sizes and comes out. So block size is what I'm saying is in a loop how much write is required, and then per execution of the thread how much data that we are going to write is the write size. And then the read weight, write weight, append weight, delete weight, these are the probabilistic operations, probabilistic values that we can do. So what actually the FFSB does is it adds up all these probability values. Okay, so now it will assign a percentage. Write weight is the probability value of the write value divided by the total of all this. So it will do the summation of all these things, and then the probability value is assigned to the write value divided by summation of all these things. So that's how we assign the percentage of the operation to it. OP delay is for after doing every operation, let's say read or write. So how much delay is required? So delay between each operation that we can specify in terms of milliseconds. So coming to the internals, how we has implemented. So these are about the profiles. We'll see the example while comparing with the IOzone. So let's talk about the internals first, and then I'll show you an example profile file also. So here the internals, what it does is, first it does the aging, and it creates a basic required files to start doing the profile. So it will start with the start files and directories, and if the aging is defined, it starts filling the data to the file system. Once it is done, primarily it will involve the sync API. So kernel API to write everything into the storage. Once it is done, the callout will get involved. This is the precondition to. So of course this is a callout is an optional one. As I told before, let's say you want to list the files first and then you want to do the profiling and callout can be assigned with the LS operation. And then it creates a n thread. Okay, whatever the specified thread groups, it will create a thread group and immediately records the time and waits for the threads to complete. Once all threads are completed, it will involve the kernel sync API so that all write operations which are there in the buffer get flushed into the storage device, records the end take a different time, and now the read throughput is the time divided by read bytes it's put down by the time. Number of bytes read, number of bytes write divided by different time. Now to look at one, this is what the overview. Just to look at how the aging happens is, for one file system, as we said, one age thread group that we can define, that is actually the number of per file system, 85, 1, okay, we will start one thread, and for each file system, we will wait for that thread to complete. Here we start the thread, and we will wait for that thread to complete. So this is what the parent thread is. Here, in this thread, we do this operation. So what we do is we create the files, keep creating the files, till actually my desired util reaches to the defined value. Let's say 20% is full. This thread will be active. Okay, once that is filled, so it will get terminated, and here this group will get completed upon the thread group. Once after doing it, we create n thread group. Each thread group is a thread, which actually creates multiple threads which are defined with number of underscore threads.
So question, this thread that is filling the file system, the aging process, is it filling the file system when it's creating the file, does it write them sequentially or randomly?
It is sequential. It is sequential. There is no random operation that we want to specify. It just fills with the data. So it is actually, okay, concept here is how much percentage of the file system that you are going to fill. Okay, so and of course it does it sequentially.
So regular thread group is also running sequential on each file, right?
Thread group actually you can make it thread group runs a thread, the operation done. So here I think if I understood correctly what you mean is whether writes happens sequentially or random writes or reads, isn't it?
Yeah.
Okay. So that actually you can specify whether it is a sequential write or random write. That you can specify. Okay. So here coming back to starts the thread. And here there is a shared variable in between the parent thread as well as the child thread. So I'll set the flag to 0, sleep for 1 second, come back, see whether this flag is set. So it has created a child thread. So in each thread, it does either read write operation, whatever the probability, the values that we have set. If I have set for this thread group, if I have set, let's say only the write, it does only the write operation. If I said both 50-50%, generally I have seen write has taken a lot of time. That's because the flushing data into the storage. Here, after doing a read write, so it will get updated with how many bytes it has read, how many bytes it has been written. So this here, the operation, what it does is, yes, randomly selects what the operation is supposed to do. So one thread.
Is it possible to turn off the random behavior so you can run the same test on different file systems? Is it possible to turn off the random behavior?
No.
Do you have exactly the same workload for each?
We can't turn it off, but we can insist. We can enforce to have only one operation. Okay. So that means how can
Actually, you can run the parallel read and write activities, right? One thread can run write.
Sorry?
You can run write and read in parallel.
Yes.
And
Yes. You can have 2 threads running it.
And for read operation, you actually need file to be prepared in advance. So when you prepare this file, is it a part of aging or?
No. Okay. Yes, the initial pointers are start defines. So what I do is I'll create, generally what it does, what the FFSP does is, it creates a dat file 0, dat file 1, the number of files that you can see. Number of files. So in that actually, what I've seen is, yes, it opens up that file, writes the data, okay, closes it. That's what it is. So it will not create a, as I've seen it, it will not create a new file. It's creating, like it was just opening with the existing one.
Respect to the aging, if it's a complex system, I might not know up front how hard to age it, and then measure time afterwards. So what do you recommend? Is there some kind of time view you can have where you see performance rise and drop, just to get to know the system and understand from what age the performance is doing?
Yeah, of course, I mean, see, that's what it is. Especially the FFSP, if you really know the file, your file system, how it behaves, I think this is the one feature that it uses. It's up to you to take a call that what percentage that you can see. Actually, what I've done with many of the flash devices, I've seen some 20-30% you start feeling it. Suddenly okay, the performance goes down because of the garbage collection techniques. This I was seeing when I was doing actually the NFC HPA feature. Generally, I used to set this as some 30%.
Another question. In case of flash, for example, or garbage collections which kick in, there might be an anomaly happening. That suddenly your read performance drops very badly.
Yeah, that happens suddenly. That happens suddenly.
Is there a way to detect such anomalies? That you can say, okay, there was a single instance of bad read performance or write performance? Is there a way to detect individual anomalies of read and write so that you don't have an average reading or write speed that would indicate that there was this one moment where it took a very slow performance or write performance? That's the way I would.
Fresh, okay. Format, general. The most, okay, here I see, I would say, most of the time what I have seen, format, fill with 25% or 30% for the plastic units. Then only you will start seeing some variation in the performance. Okay. Of course, for the, as you said, one write immediately drops down, and another write, I generally get average performance. So, but when I'll see is, that's what, if I filled with something, otherwise you have to wait for longer time to go just to make sure that it kicks in, fill the data. That's what happens. Okay, so this module is there, you can see it in main.c file, not many files are there, of course. So the version which I have seen is FFSP 6.0 RC2. Okay, so let's take a look at IOzone. Here I'm not looking to what all the options are there. I'll briefly set up, see what all the modes that we can run it in run with the IOzone. That's because I believe the IOzone is quite older and a lot of people knows about the IOzone options. IOzone, the options, we don't give it as a separate file. So we just give it with the command itself. The very good feature which I like about IOzone is it gives the Excel format output, which I haven't seen with the FFSP. And other thing is, this IOzone runs in 3 modes. One is the default, nothing you have given. So what it gives is you just executing with IOzone with what is the output file that you wanted to see the results. It will run with some predefined file size and gets the throughput. Auto mode, throughput test. IOzone actually does in the process as it executes, or it can use the fork also, child process also. And there is an option in IOzone said use the P threads, which is actually similar to the FFSP. And here we don't have a file system aging and we cannot set up the how much time that IOzone has to set. It generally executes till the write completes or read completes whatever the operation that you have. So one example here I have given as -A, which is auto mode. If I specify -I is use the direct IO, don't use the buffering. My -N is minimum file size, -G is maximum file size. And while creating a file or doing while writing a file, how much while creating a file 64 MB file, how much is your write block size? That you can specify with -R. -0, -1, I think these two options specify what are the operations. So these two actually specify read, write, reread, rewrite operations. And there are, of course, other values for creating, deleting and all, appending the data and deleting and all. And here, compared to FFSP, there is no random selection. We will not give you which is the most problematic operation that you want to execute. So here, if you specify what is the operation that you want to do, so it is a guaranteed selection of the operation. Let's say if I specify read, write, append and all. So what it does is, it does the write, does the read, does the append, comes back. In FFSP, you can probability, you can set it actually. Let's say if I set the append is the lowest probability, it may not execute also. So coming to default mode execution is very simple, IOzone, and what is the output Excel format you want to receive the output. So in the default mode, it performs all operations, read, write, rewrite, uses the F-read, F-write, everything, with the standard 512 KB file size. And 512 KB file size is read and written with 4K block sizes. With IOzone default mode, you can specify whether you want to do direct IO or you want to do the buffered IO. And there is no maximum and minimum file sizes that you can specify here. It's always the fixed size. Auto mode, you can specify with -A. With this, actually, you can specify what is actually the minimum and maximum file sizes. So what it does is, starting from minimum file size to the maximum file size, it does the read-write operation and gives you the throughput values. So here simple logic is auto test function which I am looking into of the IOzone.C file version, IOzone version which I have taken as 3.397. So starting from minimum file size to maximum file size. Let's say you are starting with 4 MB to 64 MB, starts with 4 MB, next iteration 8 MB. So it doubles. And the record size, if you are specifying the record size, it will constantly uses that record. So that is with -R and whatever the record size that you can specify. If the record size is not specified, default record will start with 4K till the file size. For example, 4 MB is your file size. It starts with the record size 4K. Next iteration 16K and the next iteration 32K. So in each iteration it doubles and reaches one record size which is equivalent to the file size itself. Okay, so here the perform test it does. Perform test could be your read-write operations. So I have taken the write perform test as an example, the IOzone.C file. So simple one which creates IOzone.tmp file. Okay, it's a default file that we would going to create. If you have specified what is the file name that you want to use it for profiling, you can specify with -F option. If you have not specified it, default file is IOzone.tmp. And if you have specified the direct IO option, so after creating a FT, it will set the FT characteristic, it will set it as a direct IO. And then it will calculate the number of blocks number of iterations that you want to write. So that is actually divided by the total size of the write operation, how many bytes you are going to write, divided by the record size. So this is the number of iterations that you are going to write. Before that, it will record the time. So complete the write operation. If -e is specified, it is actually write in sync. Write in sync means flush the whatever the write data you have, flush it to the storage device. It does the fsync operation on the file, particular file, and then record the end time, take a difference, and write rate, calculate the write rate. So that is by how many bytes that you have written and the difference time. So that's about the auto mode. So this is the same auto mode is existing for read operation, append operation, delete also. So here the throughput test, the other mode is the throughput test. In the throughput test, we specify the option with -t. So if you are using a P threads, so you can specify it with -t, and you can specify how many threads you wanted to run. So this is something similar to the FFSP. Okay, you can specify how many threads you wanted to run. Another feature with IOzone is you can specify the minimum number of threads to maximum number of threads also. So that it will does the throughput test with starting with minimum number of threads to maximum number of threads. And of course, where you want to dump the results. Okay. If you have not used the -t, what it does is it uses the fork call. It uses the process. Okay. If you have used small case -t to specify how many threads you wanted to run, then the -l and -u will not have any effect. So smaller case -t has a priority over these two options. In the throughput test mode, it will always uses the fixed file size, which is of 512 KB. And the iteration that it starts is minimum number of threads to maximum number of threads that it takes the count. Okay. So first time 2 threads do the throughput test. Let's say my minimum number of threads is 2, maximum number of threads are 4. It will be 2 iterations. First iteration will be 2 threads. The second iteration will be 3 threads. So third one, the last iteration will be 4 threads. So in the throughput test, I have considered a function called throughput test in IOzone.C file. Record the time, create the threads, wait for thread to complete. Okay. So this thread will do read write whatever specified option. Okay. Record the end time, take the different time, and calculate the throughput. So I have taken here the write test, how it takes. Create a dummy file. Okay, until unless you have not specified any file to use it for profiling. So it will use the standard W file with the thread number. Okay. Calculate how many iterations that you wanted to write. Okay, that is with standard 512 KB divided by record size. Start. Okay, calculate the start time. Then do the write operation. If sync is specified, flush the data to storage device. Record the end time, take the difference time, calculate the write rate. Similar operation happens for read also. So that is about the internals of IOzone. So here I have seen in both the implementation, in FFSB, there is an option called write. There is another option called write sync. If you are using a write sync in your profile file, it does the fsync API. Here, if you are using -e, it uses the fsync API to flush the data. Otherwise also, in write operations of the FFSB, it flushes data by using the API fsync API. Okay, so what it means is the buffering calculate. Okay, so here the write operations time is calculated need not be with the buffering. Need not be with the flushing. So it can be with have a write operation, calculate the start time, have a write operation, calculate the end time. So until unless in IOzone, user has to explicitly specify whether you want to flush the data to storage device or not. In case of FFSP, it does it randomly. So that we can see while comparing the results. So coming to how we can port these two tools, quite simple. I have tested this on the BusyBox. First thing what you have to make sure that all your ARM library, cross-compile libraries copied into your BusyBox libraries, BusyBox zip folder. Once you are done, change your the make file. Change your make file of the IOzone tool so that my compiler CC and GCC will point to the ARM cross compiler. Once you have done that, do the make Linux. Make Linux is what actually for IOzone is available for Windows also. So that's why you have to in the make file. While executing a make file, you have to give the which OS that you are building this tool for. And once that is done, copy the IOzone executable into your BusyBox. A similar thing is for FFSP also. Make sure that you have all your ARM libraries into your BusyBox library. Once that is done, modify your FFSP make file so that my CC and GCC environment variable point to the ARM compilers. Do the make. I haven't seen FFSP for Windows and other OSs. So make is enough. Copy the FFSP to your BusyBox. Now coming to the results part. So I have used this system, which is Dell with the Intel Core i7 with this flash device, which is a 4 GB transient card. With this I have seen with buffering, without buffering and all. IOzone and FFSP. I see that the read numbers, the read numbers are unrealistic numbers. This is because of the buffering. See the write numbers, 45 MB for IOzone, 5.5 MB for FFSP. It's a huge difference. So when I start looking into the code, the one thing I noticed here was IOzone does the write and records the time. It doesn't care about the syncing operation. It doesn't care about flushing data into the storage. It does only when the user has given a -e option. A user has to explicitly Is it there in FFSP also? Yes, of course. In FFSP also, we can specify the operation name as write. And of course, there is another operation that we can say is write sync. Okay, it actually eventually both the tools will use fsync for flushing the data. But here in FFSP, I haven't seen that different. Okay, in FFSP here, because of this sync operation, what it does is if I go back to this one here, this has an effect. How many threads you use, how many writes you do, so it sync. Okay, it will flush into the storage and then take a end time. So this we don't have it in IOzone. IOzone it is pretty straightforward. Do the write, sync only if you have specified the -e option. So this is what the difference which I have seen. So I changed the code actually, IOzone code. Okay, after doing the write, do the sync API. Or else I use with -e option also. So I started seeing something like the performance is of 10 Mbps instead of 45. So I started seeing some 10 Mbps. Still there was a difference of 4 Mbps. I couldn't able to figure out that, maybe because of the way the implementation they might have done. But in general, it is still okay. Or it could be at that moment I might have seen it. But I tried with several devices, even when there is a SATA hard disk with this, still there was a difference. But one thing which is we can notify is definitely the syncing usage of sync API and usage of fsync API has an impact in making the performance. If I use the direct time, interestingly, both the tools gives almost the same performance. Okay, in case of read, both read and write. Okay, so if I use the write with sync, see write with sync of IOzone 5.7, 5.5, almost same. Okay, and this gives 6 MB. Of course, this varies in between 5 to 6 MB. So what I have seen is FFSP, write performance, write operation performance, and write sync performance both are same. So write sync you do not reduce it. Okay, so this is one factor which mainly I observed, and this is what actually triggered me to start looking into the FFSP code, because when I started using FFSP, I started seeing performance difference mainly with respect to write operation. So after discussing all the internal details of how the code it will be and what it is, and what all the profiling and other thing, okay, we can take an example to see. I tested with this. I've taken 2 example profiles. One is 2 thread groups, other is 1 thread group. Difference between these two is there is no difference in terms of how much data that we are going to write, how much data that we are going to read. Here the difference is the number of thread groups. But again, in each thread group I will be having only 1 thread only. Here I will be having a single thread, but I will be having 2 threads. Okay, so you look at carefully. Here I have a write wait. So here what it means is 1 thread group I have dedicatedly for doing the write. Here I have another thread group which does only read. Here I have 1 thread group, in that 2 threads, but for each thread I haven't specified what operation to do. Here I would say, instead I would say write weight is 1, read weight is 2. What it means is my probability of read operation should be more than the write operation. And time to execute this profile is 300 seconds. Time to execute this profile is 200 seconds. See the difference in the output by the FFSB itself. The read throughput is 13 MB, in example 3.86 GB. Of course, for this card it is unrealistic. For example 1. Apparently, I was expecting the same performance because ultimately total number of threads are same here. I'm using 2 threads here, 2 thread groups, but 1 thread. So, what is it? The differentiating thing here it was, I've seen this thread group 1, which is assigned for read rate, has kicked in many times, and it has done lot of read, obviously. So what it is supposed to do is time here it cannot cross 200 seconds. So what it has done is it has read lot of data. In case of this, threads are kicked in, but probability if this operation, even though read rate is more, whenever the write has kicked in, write operation has taken more time. So number of the bytes read in this case it is less. That is why I am seeing the less read performance. So always, this is something that I would say the FFSP users has to be very careful. This is in fact leads to confusion also, because since it is the probability weights that we are giving, don't know, even though with the two threads, you don't know which operation kicks in at what time. So better to use it in this fashion. Yeah. But this is also difficult to trust. 13 MB is also not difficult to trust. So, this is with the buffer. So, example 1, I have used it for this results with this. And IOzone, I have used it with R1. Okay, so most of the tools, including IOzone, it aligns with the results. Okay, even though direct IO is disabled, we are using buffering, but still read throughput drops. I thought it was only for this card, but I tested with SATA hard disk and all. It's the same thing. There is a drastic difference in between performance.
It's cache performance, system cache performance, not release performance.
Sorry?
It's not at least actual performance.
Yeah. 13 is also not the exact performance supposed to be. That's a concern. Okay, to take up the summary, FFSP has only P threads. Whereas IOzone, whenever you execute it, it just executes in that process. Or you can specify it as you can use the fork also, the child process, or you can use it to use the P threads. Of course, FFSP takes the profile files, and here it is, you can specify along with the command. Both the tools has a direct IO options, as expected. And the Excel format output, IOzone, yes. FFSP, there is no Excel format output at all. And picking up the operation, whatever the weight order that you do, based on that weight order, FFSP randomly select the operations. But it makes sure that you are given a weight order, right weight order more, okay, a little bit more, okay, right operations will be more compared to read. Here it is linear. Start the right operation, complete it, report the performance, do the read operation, report the performance. File system aging, with IOzone, no file system aging. With this, yes. And the execution time limit, yes, we have. IOzone just completes till the operation, till the benchmark completes. Whereas in this, let's say you already kicked in the right operation, you have crossed the time limit, let's say 200 seconds, whatever you have given. It completes and comes back in FFSP also. But if you are about to start a new thread and if it checks the time and all, if it has already crossed the time, it will stop. So that's what the time limit that you can specify with the FFSP. So not much references, the only code and just to start with the readme file only. So these are the places that you can get this code and little bit documentation. And of course this can be used, this PPT can be used as one documentation. What are the references? And any questions, offline questions, anything that you can ask me or me or my colleague, Saurabh Pradhan, is another part of this. Send us a mail or anything so that we can look into that. And any other questions now? Okay, so I have my personal comments on this.
So back to the read performance, you mean that FFSB and IOzone don't flush the file cache before starting the read tests?
It will be flat. Oh, sorry.
There's no file cache flushing before starting the
Before
read
starting, yes. In IOzone also it will flush
the
things and then start it. But the thing is, IOzone does the read operation, records the time. Nothing. So there is no flushing in that. So for the write, if you write also the same thing. Do the write and record the time. In IOzone case, if you want to flush it, you have to externally specify with -. Whereas in FFSP automatically does it through sync API. That's it.
The sync is for writing.
Is done before reading? Or no? In case of
FFSP does the sync in two places. One is once you do the aging and start writing it, do the sync so that it will flush into the storage. After that, start the threads, record the time, wait the threads to complete, do the sync, and then record the end time.
It's not only about sync. Sync is for writing, but for reading, it seems the file cache kicks in, right?
No, sync,
as you said.
Sync don't have any impact on reading.
Yeah, no.
It has only impact on writing.
I don't understand why you have such
Like 4 gigabytes per second performance on read, which is too fast.
I'd like to understand why we got 4 gigabyte read performance.
Read performance.
Was direct mode?
What is given your second read? First time real read. Second read is actually read from the cache.
Yes.
There is no way to specify flash or drop caches before read.
Yeah, drop caches.
Not real numbers for read.
It is actually the complete. Okay, both the things actually can specify. For the FFSP, send a direct IO to one. Okay, but But the problem here is, okay, we cannot have it only for read. It will impact the write also.
The point is not doing flash or drop caches for the read at all. Otherwise, it's not such numbers.
Sorry, come again.
It looks like there is no drop caches for read at all. You always read using read from cache.
No, no. Here, see the read operation. 7.3 MB. What I'm saying is, yeah, use the direct time. Set this direct time to 1. Don't use the cache. Okay. Here, thread group actually can specify do only read for FFSP. For IOzone, use -E option. Sorry, use -I option. Use direct time. -E is for write to sync. That's possible.
Is there an option to add idle time between the preparation, completion, test itself?
No, there is no random time. We can specify for
idle time between the preparation stage.
For FFSB there is.
Yeah.
For FFSB, OP underscore delay.
Oh, okay.
That's does that right? Okay, stay for whatever specified time, then start again. Okay, while starting again, that's what. Okay, this thread actually does some operation, sleep for some time, again come back.
This is for thread itself, but what about aging thread?
Aging we do.
After aging, you
After
need to
aging,
start the
I'll invoke the callout. Callout can be whatever the command that you can supply to it. For example, let's say you want to print the time. So callout can be assigned with the time command. It's a precondition. Whatever the command that you can specify, that will get executed and then start the benchmark. First do the aging.
I see.
And whatever the command, you can have a script to have some idle time.
Can run
That's
it
possible.
separately.
Yeah.
Difference in performance when writing using direct I/O versus FSync. Where does that work?
Sorry,
So the bottom two lines, the writing with direct I/O is very slow, and then the FSync is faster. So what's different with this?
this one?
For example, FFSB, the 2 megabytes per second versus the 500 kilobytes per second. Why is there this difference?
Sorry, come again. I didn't get it. See, this is 5.767.
Yeah, and then the 6 versus the bottom, the figure on top.
Here.
So this, what's giving this?
Oh, with sync. Oh, okay. Oh, what you were expecting was these two. Okay, you were expecting that these two should be same.
Maybe more similar?
It should be similar.
Yeah.
What else? Okay, what I can, yes, in general, what it could be is every read, even a single clock read, it will be from the device in case of direct time. So here in the sync actually, so here my kernel can collect the total number of blocks and flush it once. Okay, that can be done.
But for read, there is no way then to observe this difference. Because if I read for the first time with caches, and if the Linux caches could do big reads on the device, which are anyhow more efficient, also than a direct I/O.
Read, yes. See this is extremely good. 6.8. Almost. I don't see. Anyway, okay, so we are going to have some personal, that's why I don't want to put it in. FFSB is definitely a strong tool, but So you use it when you really stress out the file system. When you really need an aging of the file system, then only I feel FFSP is I would say if you are generally taking up some performance numbers, you also still works good and other numbers matters. And while using FFSP, just concentrate on how you organize your profile files. Make sure that one thread group operates only on one file system. If you don't specify the bind FS, which file system to it bind, don't know which of the file system the thread group operates. So it's difficult to operate on get the even though we get the performance numbers, difficult to justify analyze on which is actually the one. And make sure that one thread group or one thread is dedicated to do one operation. That's my personal choice. I seriously didn't like the randomly selecting the operation. So as you are asking that was your question, right? How can I enforce it? So this is how I can enforce it. One thread group, I have only the write weight as 1. Read weight I'll set it as 0. Another thread group, read weight to 1. Write weight as 0. So this thread group will do only read, and other one will do only write. Okay. Of course, both things will exist in parallel. That's all. Thank you.